So hello, we have ETAP real-time system running for the power management system of water treatment plant located in Colombia, and we have developed a web server in order to check the intelligent load sharing module that is implemented in the plant. So in this case, we can simulate all the power plant consumption of the different buildings. Here we can also control we can also control here all the power of the generators. Here, so we have in the system two main incomers, two utility incomers. Only works one. Never works two in parallel. And here we have up to 7 generators running. Okay, here we can see all the loads that we have, and here we can open manually and close manually the different breakers in order to simulate different power conditions. And here this is the situation. No? So we have now we from the utility we read, so we get almost 2.6 megawatt. We generate 2.5 megawatts, and the total. So we do not control all the breakers. So so that's why okay, this is the total power, the total power plant, and these are the breakers that we have control with the ILS. So this way, so we can check the results of the ILS. So this here comes if the ILS will order to shed this breaker in case that we lose this incomer. Okay, in this case we are only testing the scenario that we are working with. We are working with the network, and if we lose this incoming, so we will act. So in case that in this situation, plus situation that okay, we are consuming from the utility 2.6 megawatts. So the ILS tell us to open these breakers. So the breakers that come here, and if the situation comes, so if I open this, so we'll see that automatically the breakers are open. Okay, and okay, so we have we have around the total consumption is this 2.3, and the generation is 2.5. So we have shed the loads that we were required. No, so I will close again the incomer, and if you see now comes again. So we have nothing to shed because we have more. We have more generation power compared to the loads. So once I start closing the breakers, okay, so from the buildings, okay, these are closed. We will see that the ETAP will make a calculation to know what it should be open in case that we have an event that we lose this. Okay, you see that these are the results that the ETAP is giving us. Okay, now I have all is completely okay, all is closed. So this will be the breakers that will be open. So in case that this is completely dynamic, so we have here I can open these two generators. So we have only 1.4 megawatts power, and the ETAP tell us which are the breakers that we should open. So I create this event, and once it's open, so the PLC act and open the breakers that are required. So now we will have okay, the plant consumption is 1.3 and the generation generator power have 1.4. So this way the ILS is automatically calculating the breakers to shed, and this is completely dynamic because will act taking into account all the powers of the plant. And also it's important to show that if the system change, that is the good thing of ETAP, as this is a model-oriented system. So I will close again all the breakers. Okay, close, I close again all the breakers. Okay. Okay, so now will comes all the power, so it's increasing the power of the plant. Okay, now we have reached to the limit, to the end. I think no, not yet. Okay, it requires a little bit time. Okay, now we have the plan already working, so with the completed power. So what is interesting to know is now I have two bus bars. So if I open this coupling, this T, so the consumption of the plant will be lower, no? So and automatically the tab will know this. The system has changed and will decide to generate different crash tables. So I open this. So in this case, when this is open, as the utility, as the power consumed by the plant is only this. So he will always only send to open these breakers. So that is the one of the advantages of a model-oriented system compared to a standard SCADA system, and that is why the ILS is a proper tool to keep the system safety running with generators. So in this case, it's completely flexible. Okay, when I close this and he knows, okay, now the power is 3.2, so he decides that these breakers will be need to shed. Okay, so for example, if I let this open, and okay, now, and if I generate this event, okay, open the main. Okay, automatically he will set this, and we have at this boost bar we have 1.3, no, what 1.3, and we have 1.4 megawatt. So we are always below the generation power of the generators. Okay, that was what I wanted to show in this video, and I hope you find this interesting.